I welcome you to my channel, The Outlier. In this section, we will be looking at the different elements that make up data science. So from a 10,000 feet perspective, we will be moving on to a 10 feet perspective. I wish to give you a closer perspective into the world of data science and which are the different elements that make up data science. Now, you might have always heard of this expression that data science is a multidisciplinary approach. It basically means that we are not looking at data science from the perspective of one single monolith. Data science can be split up into different components, into different ideas. And these ideas are what I'm trying to impress upon you in this particular slide. Let us look at the first and the most important piece in the world of data science, which is statistics. Now, as you all know, statistics is a very, very popular and a very versatile subject. It is used in different fields to derive worth and value out of the data set. Statistics is the backbone of data science, if I can say that. And statistics has been around for the last 200 plus years. Now, whenever you hear a person talk about mean, median, mode, normality, or ANOVA, or t-test, or Pearson's correlations, Spearman's rank correlation, time series analysis, autoregressive integrated moving average, factor analysis, cluster analysis, those things. The moment you hear a person saying all these things, remember that we are talking about statistics. Statistics has different schools of thought within statistics. There is what is called as a frequentist approach and a Bayesian approach. These are all different schools of thought which can be used, which can be applied to derive worth and value of the data set. So this is one of the most important elements in data science. With this, let me just make a move on to the next important element in the world of data science, and that is computer science. Now, today, when we speak about a decision tree or neural network, support vector machine, and such things, please remember that as far as the theory of these algorithms are concerned, it was not written today. It goes all the way back 60 to 70 years back. For example, if you look at Pitts and McCulloch's earliest prototype of neural network that was proposed sometime in 1940s. If you look at the Hebbian theory, again, it was proposed in 1940s. Though the theory was always there, but the practical application was missing. People could not apply these algorithms in a big way because our desktops were very, very weak during those days. Till such times as our desktop became very, very powerful, till such time as our desktops became very strong and powerful to operationalize the theoretical aspects of neural network, decision tree, and such algorithms, we could not think of the practical applications of each of these things. Computer science, in that sense of the word, plays a very, very important element in the world of data science, and that is the second most important and crucial piece as far as data science is concerned. Let's move on to the third crucial element here, which is technology. Now, imagine that you walk into a retail outlet. Let's say you walk into Reliance Fresh and you ask the person to give you monthly transaction figure. You happen to take a printout of it. You will see the printout roll endlessly. Now, unless you have an Albert Einstein-like mind, you will not be able to process it. You can't take mean, median, mode, or you can't apply some of these statistical principles manually. Manually, you can't do the computation, and therefore you need the help of technology to store the data, to analyze the data. You need technology in a big way because unless you use technology, it is not possible for you to process large sums of data. So when we speak about RDBMS, Relational Database Management System, that goes back to 1960s, the concepts of RDBMS and such things. OOPS concept, again, it's easily around more than 30, 40 years old, right? And finally, if you think of Hadoop, which is split up into HDFS, Hadoop Distributed File System, which is basically the storage unit of Hadoop. How do you store structured data, unstructured data within the framework of Hadoop? That is what HDFS speaks about. That is almost like 10 to 12 years old, at least. Could be more than that, but at least you can say that is 10, 15 years old, as far as my memory is concerned. Now, you need technology because, as I said, without technology, you will not be able to process large sums of data. So these are the three crucial elements: statistics, computer science, and technology. Let me just move on to the fourth bit here. Very, very important, visualization. We are going to borrow a lot of principles, a lot of ideas about visualization. Now, when we speak about visualization, you can think of a bar chart, pie chart, 3D diagrams. You can think of very, very attractive ways of visualization using ggplot or some other package of different tools. Now, why do we visualize data? Remember, human mind, I've told this earlier, I'll say this again, human mind is not very efficient in processing large sums of data. And number two, human mind cannot understand anything but two ideas. One, human mind can understand images or pictures. Second, human mind can understand stories. So since if you are giving a large table, let's say you are trying to summarize the COVID cases, and you have 20, you have the information about total deaths, total recovered cases, total infected cases for all the states and union territories. That will be a humongous table. In today's day and age, nobody will have the patience or the time to read, to go through each and every number corresponding to each state or union territory. So a better and an easier strategy of conveying the benefits of data analysis to the last man on the street would be through visualization. The same thing if you're able to show through a pie chart or a bar chart, that looks appealing and people can easily understand, people can easily comprehend what is going on, what is the story that that is being conveyed to the end user through your analysis. So visualization tools are the fourth and the most important element. I say most important element because there is no point applying a very, very complicated algorithm. But if you're not able to understand what is the output, if you're not able to take the benefits to the last man on the street, the analysis, all the good work that you have done will die. And therefore, to put life into these numbers, we take the help of visualization. This is the fourth most important tool. And the fifth most important element as far as data science is concerned is operation research and mathematics. We all have heard of optimization techniques, simplex method, Charles Bigham method, PERT and CPM, transportation problem, and such things. Or when it comes to optimization and optimizing techniques, techniques which help you do optimization, OR and mathematics become very, very crucial. So these are the five elements: statistics, computer science, technology, visualization, operation research, and mathematics. These are the five crucial elements which make up data science. Now you know as to why data science is very, very powerful, because we are borrowing the principles, we are borrowing the ideas from each of these disciplines, and we are applying it on the data, sometimes to store the data, sometimes to analyze the data, to sometimes report our findings to our managers, sometimes to deploy a predictive model and get the results and take the output back inside and relearn the relearn the model. So all these activities happen in data science, and therefore we need different elements of science, technology to operationalize this. Now, please keep this point, please keep these five ideas in mind, because the next slide might slightly be intimidating, but I request you not to be intimidated with the slide. Next, the following slide. We need the understanding of this slide to make sense of the next slide. Now, when you look at data science, in the last slide, we've seen that there are five different elements. I know that this slide looks very, very busy, but don't be frightened with this. You can see five lines, and each of these lines correspond to one of the disciplines. The first line corresponds to computer science. Second line corresponds to data technology. Third, visualization. Fourth, mathematics, operation research, and fifth one is statistics. And at the bottom of the slide, you can see the evolution of these technologies with respect to time, from pre-1800s all the way up to 2010. We have tried to showcase as to how each of these disciplines have evolved. The best way to understand this slide would not be to go through the nitty-gritties of each and every discipline, but to give you a high-level perspective, whether it's computer science or data technology or visualization or mathematics or statistics, compare them to streams of water. Each stream of water begins at a particular point, and after moving through a certain distance, it converges at a point. Let's say you have one stream of water which starts at place A, moves to B, C, D, E. There's another stream of water which traverses a different journey, but it meets the first stream at the point E. The same goes with the stream of water for the third, fourth, and fifth. All these three streams of water meets at a particular point where it becomes a river. Right. The same way, each of these disciplines have gone through many modifications, changes. There are many researchers, scientists, statisticians, data experts who have worked for centuries, and they have brought it up to the shape and complexion that it is of today. So today, when we talk about data science is a amalgam. It is a combine of each of these disciplines, and we are leveraging the principles, ideas of each of these disciplines to derive worth and value of the data. Remember what Mukesh Ambani said, data is the new oil and intelligent data is the new petrol. Data by itself has value, but it is not very, very useful unless you process it. To process data, we need technology. To operationalize this, we need the principles of machine learning, statistics, and finally, to report it, we need to apply the principles of visualization and such things. So each of these streams have undergone many modifications, many levels of change, and that's the reason why data science has become so very powerful as of today. Thank you so much for watching this section. I'll see you in the next section.